Hi there, so today we're looking at 5.5, solving inequalities. So our objectives today, to be able to solve linear inequalities with unknowns on one side or both sides using the balancing method that we've looked at earlier in this chapter, and to solve double inequalities. So prior knowledge check then before we start. We should be able to solve simple equations and equations with unknowns on both sides. So simple equations such as 3x plus 2 equals 14, and ones with unknowns on both sides such as 4x plus 7 equals 3x minus 4. Remembering when it says we want to solve an equation, it means we need to find the value of x. You should also be able to read and understand the inequality symbols. So we've got less than or equal to, greater than, and greater than or equal to. Make sure you're happy with those before you move on. So to start with today then, we're going to start by solving simple linear inequalities. So if we have a look at the inequality, we've got x plus 3 is greater than or equal to 7. Now remember, we did this before when we did our simple linear equations, and we had an equal sign in the middle, meaning that x plus 3 could be equal to 7. So all we're doing this time is using a different symbol. So that's just telling us that the value of x plus 3 could be any number that is equal to 7 or greater than 7. So to make this inequality true, we find the value of x. So if we wanted x to be equal to 7, we would subtract 3 from both sides. If we subtract 3 from both sides, we get x is greater than or equal to 4. So what's that's telling us is x could be the value 4, or it can be any number that is bigger than 4. Okay, so some examples then of some of these simple linear inequalities could be if 2x is less than or equal to 12, then again to find the value of x, remember 2x means 2 multiplied by x, so to get rid of the 2 we need to divide both sides by 2. If I divide both sides by 2, we get x is less than or equal to 6. Another one. This type, remember, x over 2 means x divided by 2 is greater than 2. So again, we want to get x by itself, so we need to get rid of the divide by 2 by multiplying both sides by 2 this time. If I multiply both sides by 2, we get x is greater than 4. This type here then, so 5x minus 7 is less than 3. So to do this is a two-step, so we're going to get rid of the minus 7 first by adding 7 to both sides. If I add 7 to both sides, I get 5x is less than 10. And again, we want x on its own, so 5x meaning 5 multiplied by x. To get rid of the 5, we need to divide by 5, so dividing both sides by 5, we get x is less than 2. And finally then, ones with brackets, so we know if we see brackets, our first step is to multiply out the brackets. So remember, we're multiplying both terms, so 3 times x and then 3 times 4 as well. So 3x plus 12 is less than or equal to 9. To get rid of the plus 12, we're going to subtract 12 from both sides. That gives us 3x is less than minus 3. And to get x, we need to divide both sides by 3. Now remember, with our negative numbers, minus 3 divided by 3, a negative divided by a positive means we're going to have a negative answer. And then 3 divided by 3 is 1. So x is less than minus 1. It might be worth pausing, take a minute to go through those, maybe note those down in your book so that you've got some examples to follow as we move on. Okay, so your turn then. So we've got some inequalities here, similar to the ones we've just looked at. Pause the video, have a go, see if you can solve these. Remember, the only difference between these and the equations that we've looked at previously is that we've simply changed the symbol. So our equals sign is now instead an inequality sign, but solving them is done in exactly the same method. Okay, let's have a look at the answers for these then. So for A, to get rid of our divide by 4, we're going to multiply both sides by 4, so x is greater than minus 12. For B, we've first got to multiply out the brackets, so we get 2x minus 6. Then we're going to add 6 to both sides, and finally divide by 2. So we end up with 2x minus 6 is greater than or equal to minus 4. We're adding 6 to both sides, so 2x is greater than or equal to 2, and dividing by 2 gives us x is greater than or equal to 1. For C, our first step, we're going to multiply out the bracket, so we get 5x plus 10 is greater than 15. We're going to subtract 10 from both sides, so 5x is greater than 5, and we divide both sides by 5, so x is greater than 1. For D, now this one is a bit more complex because it says a third x. Remember, a third x, though, if I multiply the numerator with the letter, that's 1x divided by 3, and if I have 1x, that's the same as x, so I can treat this the same as x divided by 3. So if I want to get rid of a divide by 3, I multiply both sides by 3, so x is less than or equal to 6. For E, again, multiply out the brackets first. We get 4x minus 12 is less than 24. Add 12 to both sides. 4x is less than 36. And divide both sides by 4. X is less than 9. Sorry about that. And finally, the last one then. So no brackets this time. We need to get rid of the plus 4 first by subtracting 4 from both sides. So x over 2 is less than or equal to 2. Then we need to multiply both sides by 2. So x is less than or equal to 4. Make sure you're happy with those answers and that you've shown your working out clearly as well. Okay, so now we're going to have a look at some with unknowns on both sides. So again, we're going to treat them in exactly the same way as we would a normal equation. So all we've got is that different symbol in the middle instead of the equal sign that you're used to. Okay, but we're going to do exactly the same. Now, the important thing this time, though, is that we can't end up with negative x's. If we end up with negative x's, our inequality sign will be facing the wrong way. So the best thing to do with these is to get rid of the smallest amount of x's first, as we've learnt to do before, and then deal with the numbers so that we don't end up with negative x's. So my first step for this one then, if I look for the smallest amount of x's, that's minus 2x. To get rid of minus 2x, we're going to add 2x to both sides. That gives me 6x minus 7 is greater than 11. We now need to get rid of the minus 7 because we want the letters one side, numbers to be the other. So to get rid of minus 7, we're going to add 7 to both sides. If I add 7 to both sides, I get 6x is greater than 18. And divide both sides by 6. We get x is greater than 3. Okay. A couple more then for us to have a look at. So this time we've got 3 minus 5x is greater than or equal to 4 minus 7x. So remember, we're getting rid of the smallest number of x's. Now minus 7 is smaller than minus 5, so it's the minus 7x we need to deal with first. So to do that, we're going to add 7x to both sides. If I add 7x to both sides, I get 3 plus 2x, so minus 5x plus 7x is plus 2x is greater than or equal to 4. Now we want to again separate the letters and numbers, so we need to get rid of the positive 3, so we're going to subtract 3 from both sides. 2x is greater than or equal to 1, and now we need to divide both sides by 2 to get x on its own. So 1 divided by 2, remember, is a half or 0.5, whichever you prefer. Last example then. So 10 minus 3x is greater than 2x minus 1. So again, deal with the smallest amount of x's first. That's the minus 3x. So we're going to add 3x to both sides. So we end up with 10 is greater than 5x minus 1. Again, we want to separate the x's and the numbers. So to get rid of minus 1, we're going to add 1 to both sides. 11 is greater than 5x. And now to get x on its own, we need to divide both sides by 5. So 11 divided by 5 is 2.2 is greater than x. Now, normally we'd like to have the x the other way around. So if we do want to switch it, we need to move the symbol with it. You can see the smaller end of our symbol is pointing at x. So if we want x to go first, then we need to simply flip those round the other way. Okay, if you're not confident with that, then leave it as it is for now. Okay then, so again, some there for you to have a go at. So pause the video, have a go, think about the different rules we've talked about as we work through it. Okay, let's have a look then at the solutions for these. So A then, x is greater than or equal to 2. For B, x is less than 2.5. C, x is greater than or equal to 1. D, x is less than or equal to 2. E, x is greater than or equal to 0.5 or a half. And F, x is greater than 2.2. Okay, make sure you're happy with those before you move on. We're now going to have a look then at solving double inequalities. So double inequalities, as you can see up here, we've got our value of x in the middle and we've got two inequalities. So it could be any combination. Usually they are less than and less than and equals to, so they must always be pointing in the same direction. We don't have inequalities where one goes one way and one goes the other way, so they will always point in the same direction. Now the way we solve these then is, again, we're going to use a balancing method, but we have to balance all three parts. So whatever we do to one, we're going to do to all three this time. So remember, again, to solve it means we want x on its own, so we want a single x in the middle. So we need to get rid of this 2 here, and it's 2 times x. So to get rid of the 2, we're going to divide by 2, and we divide all three parts by 2 this time. So we do 4 divided by 2, 2x divided by 2, and the 8 divided by 2. And we get 2 is less than x, which is less than 4. And that is now solved. We've got a single value of x with our double inequality. So essentially we're doing the same thing, but whatever we do to all three parts instead. So looking at our next example then, 4x in the middle. So again, we want to divide by 4 this time. So we have to divide all of the parts by 4. So minus 12 divided by 4 is minus 3. 4x divided by 4 is x, and 10 divided by 4 is 2.5 or 2.5. Okay, so your turn then. Pause the video, have a go, see if you can solve these double inequalities. Okay, let's have a look then. So the first one, we needed to divide everything by 2. We end up with 2 is less than or equal to x, which is less than or equal to 3. For B, to get x on its own, we've got to divide everything by 3. So we get minus 3 is less than or equal to x, which is less than or equal to 3. So remember, we're just keeping the same inequalities we've had in the question. For the next one then, we're going to divide everything by 4. So minus 16 divided by 4 is minus 4. 4x divided by 4 is x. And remember, we can't divide 0, so 0 divided by 4 is still 0. If I have nothing and try to split it into 4 equal pieces, I would still have nothing. So just be careful with that 0. And the last one then, we need to divide everything by 5. So we're going to get some decimal answers this time. So minus 1.4 is less than x, which is less than or equal to 4. So we're just making sure that our inequalities are the same ones that we started off with in the question, and we're applying whatever we do to all of the three parts. Check you're happy with those answers. Okay, moving on then to two-step double inequalities. So the only difference we've now got is that in the middle of our inequality here, we've got 2x plus 1. So we're going to do it in 2 stages. So first step, we get rid of anything added or subtracted. So to get rid of plus 1, we're going to subtract 1 again from all three parts. So we get 8 is less than 2x, which is less than 14. Now we divide everything by 2. 4 is less than x, which is less than 7. Our next one then, so again, 2 steps. Let's get rid of the subtract 3 first by adding 3 to all the parts. So we get 8 is less than 4x, which is less than 16. And now we'll get rid of the 4 by dividing everything by 4. So 2 is less than x, which is less than 4. The last one then, the only change we've got is we've got some negative numbers here and here, so we need to be a little bit more careful. So to get rid of plus 2, we're going to subtract 2. So minus 4 subtract 2 more is minus 6, is less than or equal to 3x, and minus 1 subtract 2 is minus 3. We're now going to divide everything by 3. So remember, a negative divided by a positive will give us a negative answer. So minus 6 divided by 3 is minus 2, which is less than or equal to x, which is less than, and minus 3 divided by 3 is minus 1. Make a note of those examples in your book before you have a go for yourselves. Okay, so some more there then for you to have a go at of these 2 steps. Remember, we're getting rid of any adding or subtracting first by doing the opposite so that we can balance to all 3 parts, and then we're doing our division. Be careful with those negative numbers. All right, so the answers for these then. If we add 1 to all the parts, we get 6 is less than 3x, which is less than 15. Divide by 3, 2 is less than x, which is less than 5. For the next one, we're going to subtract 5 from all the parts first of all. So minus 3 is less than 3x, which is less than or equal to 12. Divide everything by 3. Minus 1 is less than x, which is less than or equal to 4. Our next one, we're going to add 4 to all the parts. So 5 is less than or equal to 4x, which is less than 15. And then divide by 4. So 1.25 is less than or equal to x, which is less than 3.75. Remember, you can have those as fractions as well if you don't want them as decimals. So 1 1/4 and 3 3/4. Our next one then, we're going to subtract 1 from all parts, giving us minus 2 is less than 2x, which is less than 4, and divide everything by 2. So minus 1 is less than x, which is less than 2. The next one, we're going to add 1 first of all. So remember, minus 7 plus 1 is getting warmer, so that's minus 6 is less than or equal to 3x, which is less than 3. And then we're going to divide by 3. So we get minus 2 is less than or equal to x, which is less than 1. And finally then, we're going to add 6 to all parts. So minus 6 plus 6 gives us 0, which is less than or equal to 4x, which is less than or equal to 21. And we divide by 4. So remember again, 0 divided by 4 will still give us 0. Is less than or equal to x, which is less than or equal to 21 divided by 4 is 5.25, or 5 1/4. Okay, so just check you're working out, make sure you're happy with each of those and that you've used your calculator correctly. Okay, finally today then, our challenge problem solving question. So Harry has 3 parcels. The first parcel has a mass of x kilograms. The second parcel has a mass twice that of the first, and the third parcel has a mass of 3 kilograms less than the first parcel. The total mass of the parcel is less than or equal to 22 kilograms. What is the largest possible mass of the smallest parcel? So lots of information there. If you want to have a go yourselves first, then pause the video, have a go now. Otherwise, we can work it through together. So starting off then, we need to work out the different sizes of each parcel based on that first parcel, which was x. So our first parcel was x kilograms. The second one is twice that of the first, so 2 times the first one, so 2x. And the third one is 3 kilograms less than the first. So if our first parcel is x, then our third one is x minus 3. All right, so you get a mark with these for writing down using the first one, the values of the second and the third. Now we know the total mass, so all of those added together is got to be less than or equal to 22. So we can write that out. So we had our x plus our 2x plus our x minus 3 has got to be less than or equal to 22. Let's collect our like terms. So x plus 2x plus x is 4x, and we had our minus 3 is less than or equal to 22. And now we can solve to find the value of x. So we're going to add 3 to both sides, giving us 4x is less than or equal to 25. Divide, each side by 4, so x is less than or equal to 6.256 1/4. Now it said, what is the largest possible mass of the smallest parcel? The smallest parcel isn't the first parcel, which was x. The smallest parcel is the third one, because that's 3 kilograms less than the first one. So we need to take 3 kilograms off of x. So the third parcel is 3.25 kilograms. That's the largest it could be to satisfy all of those inequalities. Okay, well, I hope that was easy to follow today. If you need to, make sure you go back through that again. That's our last bit on inequalities. We're going to move on next lesson to having a look at formulae.